Right, grade 11s, now that we've looked at a summary of the three kind of types of reduction we've done so far, we need to practice a whole bunch of questions. Reduction is something that becomes really easy once you're well practiced. We do have one extra type of reduction to do, but that'll be in a little bit of time because it's slightly different to these ones. Now we're going to do two examples in this video. The first one is something we call non-numerical examples, so they've got a whole bunch of like thetas in them. And then the second example is going to be with numbers. So that will be a numerical example. So let's look at question A. Simplify, and the question says sine of 180 plus theta. My first thought is I always need to know what quadrant I'm working in. I also need to realize which quadrants are positive and negative for each ratio. So all stations to Cape Town. Eventually you get so practiced at this that we don't bother drawing a picture. But if you ever lost, we just come back to the picture. So where is 180 degrees plus theta? Well, that would be 180, so plus theta would land me up in quadrant 3. So now I need to make a decision. Is sine negative or positive in quadrant 3? Sine is negative, so this reduces to negative sine of theta. Now I move on to where is 180 degrees minus theta? Now that would be in quadrant 2. And so then I would say to myself, what is the sine of sine in quadrant 2, and sine is positive in quadrant 2, so this simply reduces to sine of theta. And my last step is just to write this as neatly as possible. So this can be written as negative sine squared of theta. Now that's generally where we put the squared in trig. You can put a bracket around the sine theta and then square it, but just notationally that's generally what we do. Right, let's move on to another example. So this first factor in this question says cos of 360 minus theta. So again, as we start to get used to this, I'm going to draw this out every time. All stations to Cape Town. And my question is, where is 360 minus theta? Well, all the way around would be 360. So 360 minus theta would be in quadrant 4. Now, why is that important? Because I need to ask myself, is this ratio positive or negative in quadrant 4? And this is cos. So cos is positive. Now you don't need that plus sign. I'm just writing in there to be obvious. So this reduces to positive cos theta. On to the next one, and I have 180 plus theta, which is an angle we've spoken about before in the first example. And you'll notice that's exactly what happens. You start to see the same things over and over again. So 180 plus theta would be quadrant 3, and sine is negative in that quadrant. So this reduces to negative sine theta. Now this is divided by, and this angle is 360 minus theta, which is exactly the same as the first angle we did. So this is quadrant 4, but this time the ratio is tan, and tan would be negative. So negative tan theta because it's in quadrant 4. So once again, I need to make this look a little bit prettier. First of all, I'd just like to simplify my signs over the whole question. Basically, there's a negative on the top, there's a negative on the bottom, they'll cancel. So this simplifies to cos of theta times sine of theta over tan of theta. Now for the moment, that's as simplest as it gets. In the long run, we're going to do something called trig identities. Now I've already alluded to these identities when we did Pythagoras type questions. And so I am going to show you how in future this can be simplified further. Okay, so I'm going to put a little bubble around this because this is not something that I would be expecting you to do at the moment. So in the future, we're going to learn that tan theta is always equal to sine theta over cos theta. I did allude to that in the Pythagoras questions, and I think starting to see this and sowing the seeds of these identities is really helpful in the long run. So in the future, there is an identity. Now, an identity is something that's always true. So tan of theta is always equal to sine of theta over cos of theta, which means in the future, we're going to be able to simplify this further, because we're going to say we have cos of theta times sine of theta, and we're dividing by tan of theta. Now, I'm just writing it like that because I know that I'm going to have a fraction in the next line. And so I'd like to avoid fractions within fractions. So now what I'm going to do is I'm going to change tan theta to sine of theta over cos of theta. Now what we can do is that grade 8 concept which we learned about, which was tip and times. So I'm going to multiply by, and not sine, I need to tip it. So I'm going to tip my ratio, so it's now cos of theta over sine of theta because I've tipped my tan over. Now you'll notice my signs cancel. Now whenever you're cancelling things, try not to squash them out because we need to be able to see what was there before. And so basically this simplifies to cos times cos, which is cos squared theta. Now this is very much in the future. I like to sow the seed of identities little bit by little bit as I go along in trig, so that when we get there it's actually quite an easy concept. This is not what I'd expect from you at the moment. We're just practicing reduction. Okay, so that was quite a fun one. Let's have a look at our last non-numerical example. Right, I'm going to draw my all stations to Cape Town diagram because I know that comes up a lot. And the first thing that comes up here is sine squared, which is interesting, of 180 plus theta. Now most people would look at this and go, oh, but I don't care if it's positive or negative. I'm going to land up squaring it, and so it doesn't actually matter. And while that's true, when I have chatted to people who mark grade 12, paper 2, they have said that they like to see the fact that you know whether it's positive or negative before you square it. So let's not cut corners. So where is 180 degrees plus theta? 180 degrees plus theta is in quadrant 3. So if this is in quadrant 3, I need to ask myself, is sine negative or positive? Well, only tan is positive, so this is negative sine theta. However, I am squaring it. Now we prefer in this case to write the square outside the bracket, simply because the negative is being squared as well. Whereas if I write it in the place that I normally write it, then is the negative being squared or not, and it gets confusing. Right, so on to the next one, subtract. Where's 180 minus theta? That's in quadrant 2. And so is cos negative or positive in quadrant 2? Cos is negative. So this reduces to negative cos theta. And then finally, 180 plus theta, we've already spoken about that. That's in quadrant 3. And cos is also negative in quadrant 3. So this reduces to negative cos theta. So this simplifies to, and negative squared is actually a positive, so this is sine squared theta. And now I have a negative, which is a positive, and a negative, which is a negative. And cos times cos is cos squared theta. Try never to simplify signs in your head in this second section. So don't leave out the two negatives because you know they cancel, because the marks are for can you reduce accurately with their sign. So only start simplifying signs in this third line. And there we go. Sine squared minus cos squared. That's as best as it's going to get for now. Right, now let's look at some numerical examples which take a little bit more thinking. Now why they take more thinking is that the reduction isn't set up for us. In the previous example, the reduction was almost kind of created for us, and then it said, cos of 180 plus theta, that 180 plus theta was already set up for us. Whereas if you have a look here, this question says simplify without a calculator. Now, without a calculator means to me that I need to do special angles, because the only thing that I know how to do without a calculator is special angles. So we're going to write down a couple of steps here. Let's look at A. Question A says, what is cos of 300 degrees? So my first step is to take 300 degrees and to rewrite it using one of our reduction techniques. So I've written myself a note here. My first step, rewrite 300, and I either need to choose 180 minus an angle, or 180 plus an angle, or 360 minus an angle. Now, that's fairly obvious here because 300 is closest to 360. So I'm going to rewrite 300 as 360 degrees minus 60. Now, please note, you can't have changed the question. So you know that you've done this right if that bracket simplifies straight back to 300 degrees. Our second step is to figure out what quadrant this angle is in. So when I'm figuring out what quadrant this angle is in, I need to look at what I've done. I've said 360 minus an angle. So 360 minus an angle would land me up in quadrant 4. Now, why are quadrants important? Because they allow us to figure out the sign of this ratio. So in this particular example, I need to figure out the sign of cos, because that's what the question was, in this quadrant 4. And don't forget, it's all stations to Cape Town. So that fourth quadrant is where cos is positive. So this is positive And I need to complete the sentence now by saying I need to reduce this cos 360 minus 60 to a ratio of theta. So this reduces to, we've said it's positive, but it reduces to cos of 60 degrees. Because 360 minus an angle will reduce to cos of just that angle. So now our last step would be actually to calculate the answer. So in this case, I'm going to use special angles because 60 degrees is a special angle. So if we're going to use special angles, you can cheat on your calculator, I'll never know. But hopefully once you've practiced a lot, we know that cos of 60 is a half. And so this simplifies to positive a half. So those are our 5 steps that we need to follow. Right, so let's look at the next one. Tan squared of 135. So what's my first step? My first step is I need to rewrite 135 degrees. So I'm going to use a bracket now, because I know I'm squaring and it's easier to use a bracket. I'm going to rewrite 135 as 180 degrees minus 45 degrees. And I'm squaring this. My next step is to figure out my quadrant. So 180 minus 45 would be in quadrant 2. My third step would be to look at the sign. If you're talking about quadrant 2, I'm looking at tan in quadrant 2. And tan in quadrant 2 is negative. So this is negative. Ultimately, I'm going to be squaring it so that negative will cancel away. But they do want to see that you know it's negative. My next step is I need to now reduce this to a tan ratio of 45 degrees in this case. So this reduces down to negative tan of 45 degrees. And so my last step is to now use my special angles to figure out what the answers are to this one. So I hopefully know that tan of 45 is 1. So this is actually negative 1 squared, which is in fact 1. So again, this appears to be the same 5 steps every single time in these numerical examples. Now the important thing is that this second step here, I call this kind of setting up the reduction. Now the reality is there's no mark for that. So there's nothing wrong once you're really good at this, at doing that in your head and skipping straight from the question to the actual reduction. I mean, it says without a calculator, but I know that you will be doing this in your head if you don't step straight to the answer. So you've got to actually do the reduction. You've got to show the sine and the tan of 45, and that's fine. Then we assume that you did the red line in your head, which is absolutely fine. Okay, let's look at question C. Question C is very interesting because my first step is to rewrite 630 degrees. The only problem is 630 degrees, that's huge. That's like bigger than 360. So the thing that's different here is note that 630 degrees is bigger than 360. Now this is going to be a concept we're going to discuss after we've practiced reduction. When I'm in class, I always say, if I face you and then I rotate myself a full 360 degrees, do I land up in a different place? Do I land up staring in a different place? And the answer is no. If you're having an angle in the Cartesian plane, so if I draw a random angle and call it theta, if I rotate a full 360 degrees, does the angle actually change? And the answer is no. If I go back and I go clockwise a full 360 degrees, again, you're landing up in exactly the same position. And so something we're going to take note of in our lesson on big angles is that you can always add 360 degrees or subtract 360 degrees, because then you haven't actually changed the angle compared to the x-axis. So I've just written that down in a note, and that's something that, again, I'm sowing the seed for later on, because this is something we're going to do a lesson on. Now, I've also said in that note that you can add and subtract 360 as many times as you want. You can just keep going round and round and round and round, and if you don't fall over, you actually would land up in exactly the same place if you were always adding 360. It's a full revolution. So what I would do here is I would have a look at 630, and I would just subtract 360 degrees and change this to a much easier to work with angle. So 630 minus 360 degrees is 270 degrees. Now we can go back to our normal kind of working. So now I can do my step 1 of rewriting 270 degrees. So in this case, there's actually two options. 270 degrees, I don't know if you know where it is, but 270 degrees is all the way around and going straight downwards along the y-axis. So either you can write it as 180 degrees plus 90, or you can write it as 360 degrees minus 90. So, or you could say cos of 360 degrees minus 90 degrees. Running out of space there, I'm just going to take away my picture so it's a bit more clear. You know, the reality is it doesn't actually matter which one you do, because our next step is what quadrant are we working in. Now, it's almost impossible to tell what quadrant you're working in because you're on the borderline. 270 is the border between quadrant 3 and 4. So some people get a bit confused as to what to do. If I thought about this as quadrant 3, I would then say, what is the sign of cos in quadrant 3? And the sign of cos would be negative. So this would reduce down to negative cos 90 degrees. However, if you thought about it as cos 360 minus 90, you would then probably think that this is in quadrant 4. So, or you would simplify then to positive cos 90. So this seems like it's going to give me two different answers. So that was my third step, which was my sign, as well as my fourth step, which was my reduction. Now the reality is in this question, it doesn't matter which way you took it, because cos of 90 is 0. And so either way, negative or positive 0 is just 0. And so that's why when you're on the borderline, it doesn't actually matter which quadrant you're thinking it's in or how you set up the reduction, because it all will boil down to the same answer. So that question was just a glimpse into the idea of angles bigger than 360. Right, let's go back to a more normal one. First question, first step, I need to rewrite 150 degrees in this question. So this is tan, and I'm going to rewrite 150 as 180 degrees minus 30. My second step is to figure out which quadrant. So 180 degrees minus 30 would be in quadrant 2. My next step would be to check out my sign. Tan is negative in quadrant 2. My next step is to do my reduction. This reduces down to tan of 30 degrees. And so finally I can do my special angles, and tan of 30 you can either write as root 3 over 3, or you can write it as 1 over root 3. Those are exactly the same thing. Your calculator gives you the first one, but often special angles, if you are remembering, then gives you the second one. They're exactly the same thing, so you don't have to worry about it. Great, so let's try a little bit more interesting examples when there's lots of reductions need to be done in one question. So this is where I'm going to stop writing down our steps and basically just talk through our steps as we go. So let's look at the first factor here. The first factor is sine of 300. So I'm going to rewrite 300 as 360 degrees minus 60. My second factor here is sine of 240, which I'm going to rewrite as 180 degrees plus 60. Now in my next term, you'll notice I have 240 again, this time with cos, so again I rewrite that as 160 degrees plus 60. And lastly, tan of 225, I would rewrite as tan of 180 plus 45. So I'm getting quite tight there. Now the reality is this line here that I've written down is not worth any marks. So you're welcome to do all of that thinking in your head. Now to be honest, if this was me, I wouldn't do that in my head. I always like to write it down. These questions are worth, 5-6 marks, and so I've got time to write that down, especially while I'm getting used to it. Okay, now let's think about it. 360 minus 60, this would be in quadrant 4. Sine is negative, so this is negative sine of 60 because we're working in quadrant 4. Next one, 180 plus 60 is quadrant 3, and again sine is negative in quadrant 3, so this will be negative sine of 60 degrees. Plus 180 degrees plus 60, again in quadrant 3, and cos is also negative in quadrant 3, so that's negative cos 60. And lastly, 180 plus 45 is quadrant 3, but this time tan is positive in quadrant 3. So this is tan of 45 degrees. So far that's generally worth 4 marks, 1 for each reduction. Now I need to do my special angles. You're welcome to use a calculator if you'd like. Sine of 60 is root 3 over 2. So I get negative root 3 over 2 and multiplied by exactly the same thing. So negative root 3 over 2. Now, these two signs will simplify to subtract. Cos of 60 is a half, and tan of 45 is 1. So you must show each of your individual special angles being reduced down. Now, you can cheat on your calculator here. Don't forget that these are two separate terms. So a negative times the negatives of positive. Root 3 times root 3 is 3. 2 times 2 is 4. So top times top, bottom times bottom. You can cheat on a calculator. And this is minus a half, the second term. Now, if I really did want to show all my steps, I could say that's great. There's a lowest common denominator. And so this simplifies down to a quarter. So this is a very common exam question. So I haven't written down the steps here, but basically every single time I'm rewriting my angle, I'm choosing a quadrant, I'm choosing a sine, I'm reducing it, and then using my special angles. Okay, let's try another one that's quite similar. First one, tan of 315. So I'm going to rewrite 315 as 360 degrees minus 45 degrees. Then I have 300, and as I've said before, you start to get so used to these. So 300 would be 360 minus 60. 150 would be 180 degrees minus 30. And lastly, tan of 135 would be 180 degrees minus 45 degrees. Now reduction on each one. 360 minus 45 is quadrant 4, and tan is negative, so that's negative tan of 45 degrees because of the quadrant 4. Next one, 360 minus anything, again quadrant 4. However, this time the ratio is cos, and cos is positive in quadrant 4, so this is plus cos 60. On to the sine. 180 degrees minus 30 is quadrant 2, and sine is positive in quadrant 2, so this is sine of 30 degrees. And lastly, 180 minus 5, also quadrant 2, but this time it's tan, so it's negative tan of 45 degrees. Okay, now that's all the hard work done, because now it's just special angles and simplify. So tan of 45 degrees is 1, so that's negative 1. Cos of 60 is a half. Sine of 30 is a half, and tan is minus 1. So negative 1 plus a half at the top is negative a half, divided by a half minus 1 is negative a half. And so what do you know? This simplifies all the way down to negative 1. So again, a 6-mark question because you've got a lot of reduction there, and then special angles and simplify. Don't forget that this step here isn't ultimately necessary, but I find it very useful, especially when we're starting out. Okay, let's look at one last numerical example. So this question says cos of 180. Now that's interesting because 180 degrees is one of the axes. So when you're looking at axes, we consider those special angles. So you could literally just pick up your calculator and go, what is cos 180? And just write it down. Because especially once we've done graphs, we do expect you to know 180 degrees. If you wanted to do the long way around, you could say, great, I'm going to write this as 180 degrees minus nothing. If you wanted to. But you could just go straight to the answer for that one. Right, on to tan. Tan 180 degrees minus x, that's quadrant 2. Tan is negative, so this is negative tan x. So put it in a bracket. Multiplied by 360 minus x is quadrant 4. And sine is negative in quadrant 4, so minus sine x. Last factor on top, 180 minus x is quadrant 2. And cos is negative in quadrant 2. So this is negative cos x. Now once again in the denominator here, we have sine of 270 degrees. Now that's an axis. So that's considered a special angle, and you could just cheat on your calculator if you wanted to. If you wanted to rewrite that, you could write that as 180 degrees plus 90. Or, as we've said before, that could be 360 minus 90. It's not going to matter in the long run. 180 plus x is in quadrant 2, and cos is negative in quadrant 2, so that's negative cos x. And finally, 180 plus x is quadrant 3, but tan is positive in quadrant 3, so it's tan x. Right, so first one, cos of 180 minus 0, that would reduce down. That would be quadrant, now it's kind of quadrant 2, or it's kind of quadrant 3 because it's on the border. If I draw myself a little picture, 180 degrees is here, but I'm not minusing and I'm not adding. Now, it doesn't actually matter because in quadrants 2 and 3, cos is negative. So this would be negative cos of 0 degrees. And if I just do the other numerical one at the bottom, sine of 180 plus 90 would be all the way down there. Now, is that quadrant 3? Is it quadrant 4? Again, it doesn't matter because sine is negative in both of those. So this is minus sine of 90 degrees. Don't forget that you could have just done both of those in your calculator because they're an axis. Now, really important, when you start cancelling out, please make sure that we can see the signs in the reduction below. So neatly, I see tan x, and I'm going to cancel it out. The only problem is these negatives everywhere. So let's first set out our negatives. How many negatives do I have in the whole question? Because this whole question is one term. So I have 1, 2, 3, 4. Now I know that 4 negatives will cancel each other all out, and my answer will be positive. So I no longer have to worry about those negatives. So I prefer to do them first. Cos is going to cancel because there's cos of x and there's cos of x. And so basically the negatives are all gone, and I simply land up with sine x at the top. Now a little bit of work here. It's cos of 0 is 1, so this is negative 1. Negative sine 90 is also negative 1. So those negative ones actually land up cancelling, and my answer is just sine x. Great. So those are pretty much all the examples that I could think of in terms of getting our basics of reduction really well done. Now these last 3 questions, any one of those could be an exam or a test question. That's exactly how they would ask them. They're generally, 6 or 7 marks, and so they're definitely worth getting right because they really are just following a whole bunch of rules. Now,